Okay, so for part three, which happens to be day two, we're going to look at taking everything that we know about graphs and vertex form and everything else, and we're going to use it all in one question. So it says, for the function negative x squared minus x plus 6, we're going to find the following characteristics, and then we're going to sketch the graph. So vertex. Again, we can go about doing this in one of two ways. You can do negative b over 2a, which is perfectly fine, which we can do here on the side, right? We have negative b, so that's a negative 1. So that's a negative b over 2a. It's also a negative 1. We get positive 1 over negative 2. So that is a negative 1/2 or a negative 0.5 for h. And then our k, we just take that and we plug it in. So really quickly, I can go negative 0.5 squared minus negative 0.5 plus 6. So this is the reason why I like to use my parentheses. And look at that. I already made a mistake. I put negative, and I forgot to put my negative 0.5 in the calculator. So I'm actually going to hit second insert and insert my negative sign that I need. And then I'm going to hit enter. I get an answer of 6.25. Okay, so I got my b or my h that I calculated, and then I used that to plug it in. You could have just as easily stuck the equation into y equals and calculated the maximum. I just didn't want to do that. So vertex form. Okay, vertex form, if I remember, I need an a is h minus k squared. Wow. A is x minus h squared plus k. Woo. So I need an a, an h, and a k. Well, I have my h, my k. I need to double check my a. In this case, a is always that number that's right in the front, and it's a negative 1. Or I could just use negative. That's x opposite sign of h, so I have an x. If that's a negative 0.5, it's going to be a plus 0.5 squared. And that's a plus 6.25 because it was positive. All right, so now I want the axis of symmetry. Well, the axis of symmetry is very easy. It's just my x value, and x is negative 0.5. My domain. Well, if I go into my calculator and if I know anything about my graph, first of all, it's a quadratic. It starts at 6, so 1, 2, 3, 4, 5, 6. So it starts here, and of course, it's going to point down. I'm not entirely sure where it's going to cross the x-axis just yet, but for visual purposes, I know that it's going down, so my domain is going off from negative infinity to positive infinity. My range. Now, if I remember correctly, right, this is actually not at 6 exactly. The maximum is actually at that negative 0.5, 6.25. So I know my graph starts at negative infinity and at the bottom and goes up to that 6.25 of my y value. So negative infinity up to 6.25. Now I want to calculate my zeros. So for that, I'm going to go ahead. I'm going to plug it into my calculator because that's the fastest way to do it. Minus x plus 6. All right, I'm going to graph it. Ooh, look at that. It looks like it crosses beautifully at negative 3 and 2. But to double check, I'm going to hit my second table. And I'm going to double check those values at negative 3. And what's the 2 is a 0. And double check, negative 3 is a 0. So my zeros occur at negative 3, 0, and 2, 0. My y-intercept, well, that's given to me. That's this guy here, that plus 6 that was at the end. Well, it's at 0, 6. Right? Don't put 6, put actual 0, 6. I want the value. Y max, well, the y maximum we already have. Our vertex is our maximum. So our y max is 6.25 when x is negative 0.5. I'm done with question 10. I took everything that I already knew and I utilized it. Remember, that y-intercept is not always the maximum, okay? They're not the same. All right, for 11, it says write the equation of a parabola with a vertex at 4, 6 that passes through the point 6, 14. So I have my vertex. So I'm going to use vertex form. So I have y equals, I know it's going to be ax minus h squared plus k. So this is my h, this is my k, and of course this is my x, this is my y. The one thing I don't have is my a, but I'm going to use it. So my y is 14, so I'm going to start replacing everything. I got 14 equals a. Instead of x, I'm going to put that 6. And instead of h, I'm going to put that 4 squared plus that 6 is k. Do the work, I get 14 equals a. 6 minus 4 is 2 squared plus 6. Well, let me see, I'm going to go ahead and move my math over here. I get 14 is equal to a. 2 squared is just 4 plus 6. I have to start solving for a. I have to move the 6 to the other side. 14 minus 6. All right, and that 4, then a, so I'm going to divide by 4. A divided by 4, or 8 divided by 4 is 2. I'm given my 2. I want the equation of the parabola with the vertex. So I'm actually going to take and just put it into vertex form. So I now have y equals my 2. This is going to be x minus my vertex of 4 squared plus 6. This is my final answer. Okay, so you just have to read carefully because you knew you were going to have to use the parabola in vertex form. All right, for question 12, it says find the following characteristics of the function, then sketch the graph. Round to 2 decimal places where needed. Very important that we pay attention to that very important detail. So, find the following characteristics of, hold on, is 12 missing? 12 is missing. Details. Sketch or graph of the function. Odd. I think that 12 is actually supposed to be the details of 13. So technically 13 should be 12. Okay. Okay, so first thing it tells you to do, it says it wants the factored form. Well, if I remember correctly, I need to know what times what gives me 8, but adds to be a negative 6. What are the factors of 8? 8 is 2 times 4. I need to add them to get negative 6, so that's a negative 2, negative 4. Okay, so I get x squared minus 2, and then I get x squared minus 4. Can I take the square root of 2? No. Can I take the square root of 4? Yes. So I actually am going to replace this x squared minus 4 because it's a difference of squares. I'm actually going to change it so that it is x minus 2, x plus 2. All right, and if you forgot, right, that's because it's x squared minus 4 breaks down. We had x squared minus 2 first. All right, so now it says find your zeros and multiplicities. Well, I have x squared minus 2. Whenever I go to solve that, I know I'm going to have a square root of 2. So x is going to end up being a plus or minus the square root of 2. Can't take it, so we stay square root. That x minus 2x plus 2, well, that just becomes a plus or minus 2. So I know I have zeros or x-intercepts at a positive 2, at a negative 2, and that square roots are just somewhere in the middle. I think they're going to be kind of like right here because it's like 1 point something. So this is going to be a narrow picture. All right, so now I have y-intercept. My y-intercept, well, that's always going to be that last term. So it's at 0, 8. So y-intercept occurs at 8. So 1, 2, 3, 4, 5, 6, 7, 8. Right, as I'm finding these things, I'm plugging them in. Okay, degree. Degree is obviously the value, the term with the highest. No, I didn't say it. The degree is the value with the highest exponent. So that is the degree of 4, meaning I'm going to have 4 value or 4 x-intercepts. The lead coefficient. The lead coefficient is the number in front of the highest degree. Well, do I have anything with that x to the power of 4? No. So it's a lead coefficient of 1. And it's positive, meaning that the endpoints are going to go, that my endpoints are both going to go up. Taking this information, I can sketch the graph, okay? So I know I'm going to actually start from this y-intercept. I'm going to go down. I don't exactly know how far down it's going to go, but if you need to, plug it into y equals and take a peek at it. Okay, so we would plug it into x to the power of 4, so x power of 4 minus 6x squared plus 8. Take a peek. Oop, he barely goes past the x-axis, so there we go. That's what I needed to know. Oop, keep that 8. So he's going to go down, barely, and up. Down, barely, and up. Looks like a W. All right, I'm done with question 13. All right, question 14, it says, what is the polynomial function that has a 0 of -3 and 2i? 2i means I'm going to have a conjugate, so I have to do a plus and minus 2i. So I have a shortcut anytime you have i's. I know I have an x equals -3. I also have an x equals 2i, and remember, if you have a positive, you have to have a negative. Now, if I were doing this the long way, I would do x plus 3. This becomes x plus 2i. This becomes x minus, sorry, wrong. X minus 2i, x plus 2i. And then I would, of course, multiply these two terms together to find my problem. But I have a way of doing this. Anytime you're given an imaginary number, you're going to do exactly what you did, but do x equals 2i. And what you're going to do is you're going to square both sides to get rid of the I. So I'm going to put this in a different color really quick. You're going to square both sides so that you get x squared is equal to 2 squared is 4 with an I squared. Well, what's I squared? I squared is -1. 4 times -1, -4. Solve it, I get x squared plus 4 is now my value, or my binomial that I'm going to use to solve. So I have x plus 3, and instead of multiplying these two terms, I'm actually just going to take that x squared plus 4 and plug him in. Now I can do my math, and I'm going to multiply them together. I end up getting x times x squared is going to be x cubed. X 4x plus 3x squared, so plus 3x squared plus 4x, and then 3 times 4 is 12. So my function, or my polynomial, is going to be x cubed plus 3x squared plus 4x plus 12. Sorry, guys. Question 15. All right, it says the number of subscribers in millions to a wireless network from 2006 through to 2012 are shown in the following table. Okay, so we have our years and we have our millions of subscribers. It says using a graphing utility, we're going to create a scatter plot of the data with t equals 6 corresponding to 2006, meaning I'm going to go in and I'm actually going to change all of these. 2006 becomes 6, 7, 8, 9, 10, 11, 12. And we're going to sketch a scatter plot out of this information. So I'm going to have to go into Stat, Edit. I'm going to clear it out, and I'm going to put in 6, 7, 8, 9, 10, 11, 12. Make sure it's all in there properly. 233, 255.4, 270.3, 285.6, 296.3, 316, and 326.5. Everything's even. Because I'm doing decimals, I'm absolutely going to go back through and make sure that I plugged everything in exactly the way that it should be. And now I'm going to do my graph. Ooh, sorry, I take that back. I'm going to go into y equals. I'm going to clear out that graph, and I'm going to turn my plot on. Now I'm going to look at my graph. I can't see it, though. So, of course, I know I'm going to have to change my window. So I'm going to say my minimum value, I'm just going to put it at 1. Because I'm going from 6 to 12. My maximum X value, because I want to see it, I'm going to put it at 15. This one's different. I'm going to look for my smallest. Let's see, 233. I'm going to put it at like 200. For my, not 200. Not that guy. He's at 1. For my Y minimum, I'm going to put it at 200. My maximum, find the highest number. It's 326. I'm going to put it at 330. That way I can see it. All right, so I have my graph. I see what it looks like. If I'm going to sketch it, right, I'm going to do this. I know, looking at it, it's looking like I have here. It looks like it's pretty steadily going up. There we go. Not perfect, but it's there. If you have to, you can do a scale. You can say that you did it from 200 to... I put 3 in the wrong spot. It's 200 to 330, and you did a scale from 1 to 100, sorry. And your scale you did from 1 all the way to, I think I said 15, 13, 15, yeah. Okay, but those are little details. It all depends on your instructor. All right, now it says, what is the equation of the line of best fit? I'm going to find that out. I'm going to go stat calc. I'm going to hit 4. And because I know I'm going to have to take a look at this, I'm going to go ahead and do vars, y vars, to make sure that my equation is programmed into my calculator. All right, my equation for the line of best fit, well, that is 15.275 x plus 145.825. Now it says, what is the regression coefficient? Well, this is your R that should be turned on in your calculator. And your R for this is at 0.99, what ends up being 996. It says, is the line of best fit a good model of this data? And explain. Well, yes, if we know anything about the correlation coefficient, it's that the closer it is to 1, the more accurate it is, right? So R is close to 1. All right, and finally it says, use the model to predict the number of subscribers in 2015. Now, in order to figure this out, 2015, right? I knew that if 2006 is 6, then 2015 is going to be 15. So really quick, I'm going to hit second table set. Since I went ahead and programmed everything in, odd. Come on, second table set. There it goes. Sorry, it was delayed. Second table set. And I'm looking at the year 15. Ah, there it goes. Don't know what's going on here. It's clearly got a delayed sensor right here. Okay. And I'm going to hit enter. I'm going to look at my second table to see that it is 374.95. So in the year 2015, there were 374.95 subscribers. Okay, now it says, use the model to predict in what year the number of subscribers will be 400 million. Well, I can use the same exact data. So if I'm looking, I'm going to look for 400 million. I notice I jump between 2016 and 2017. I jump between from 390 to 405. So I actually need to look and plug in what I'm going to assume is 16 into the equation that I got. So I'm actually going to see I have 15.25 times 16 for the year 2016 plus 145.825. Let's see what I get. 15 point. Oh, that's a 2. My equation, I plugged it in wrong. Sorry, guys. What's my equation? 15.275. I'm missing a 7 right there. Look what happens if you don't put, if you're missing one little digit. So 15.275, very important detail, times 16 plus 145.825. Okay, now that I have the right number, 2016 was 390. Okay, so now, oh wait, I already knew that. Now I actually need to take that 400 million, set it equal to C, 275. I'm looking for the year as close as I can, so I'm going to do 145.825, and I'm going to solve for X. How do I solve for X? Well, the same way I would any other. I'm just dealing with more decimal points, which means I'm going to have to use my calculator. 400. Well, my calculator's not wanting to work. Whenever you do the math, minus 145. Hopefully this will do it while I'm delayed. I'm going to divide by that 15.275. 16. I'm going to end up getting an X that is 16.6